try to understand what is coming for the next 6 months to 1 year. That is really important. So if you see, I have spent a considerable amount of time in the Swarm, and now uh, still I would say that is not going to vanish, right? Swarm is still used to basically simplify the Kubernetes. So if I am using Swarm, if I want to set up a Kubernetes, I will use the same set of tools to bring up the Kubernetes. So it is very important to basically be close to the community and try to understand what is coming up. So today, earlier they said that Docker is not secure. Docker is not secure because your host operating system is not secure. Then why don't you? Docker has given you a product called as Moby, which you build your own Docker distribution, right? I can build my own distribution. I can run on my Dell server or any of the servers, and I will make it secure, right? So if I am continuously saying like it is not secure, it is because I am implementing it in the wrong way, or I am just installing Docker and I'm saying like I'm opening all the ports, exposing my containers to the outside world, and I'm saying it's not secure, right? There are tools which you can use both in the enterprise and the community. You just have to use that tool, right, in an efficient way. And Moby is one playground where you build your Docker distribution. So if you see the Docker platform which supports Kubernetes, it is because of Moby and Linux Kit. You use those tools and run your own distribution.
Moby and Linux?
Linux Kit.
Linux Kit.
So Linux Kit is a very small OS. So today you might have seen this RHEL Ubuntu distribution, right? Why don't you create your own distribution itself with the Linux Kit? And whatever you need, you just package that and install it on your machine. So, and that is completely read-only. Okay, that Linux Kit is basically very small OS which you run, and whatever the services you need, you just run those services. So that could be one approach where you say, okay, I have built my own Docker distribution. Now, if you rely on, if you need, one of the problems which it has been faced is like there has been so many. I was looking at Docker for Mac itself. So there has been so many users using. They are using the yeah.
Sorry, sir.
Yeah.
No, live streaming.
It started.
Yeah.
So that be like I had presented Linux Kit in last Docker Meetup. So I don't know how many of you were there. So I gave a brief about how to build your own.
So the videos are there if you want to check it out.
Yes, videos are there.
So where you click? So what's a link or something?
Yeah, it's you can you can go to the Google and search Linux Kit, Docker Linux Kit, you will find it out. So we have a bit of it.
Good question. When I roll my own distribution using Moby, I still have a dependency on Docker to address this question, like downstream. I still have a dependency on Docker.
So you build a Docker distribution using Moby.
Yeah. So
you can use an Ubuntu.
Does it package the engine also inside? the daemons also inside?
So what is happening is very just like an example of Alpine. I want to build my own Alpine with certain services. I can use Moby to build it. So the Docker doesn't come into the picture in that way.
Doesn't come. So there is no dependency on Docker as a company. So that was his question, because when he embeds it into his device,
Let me see how much I have.
Does he have a dependency on
Docker? We don't have. Docker has become just a CLI now. It is a platform, but it is just a CLI you use. You run a container inside it. That container is based on the container D. That's why
container D.
So runtime, earlier it was Docker. Now you have a container D as a runtime. So we have a number of runtime sources. So we'll get started.
Yeah.
Maybe at the end.
So the Linux Kit is on the open source version or the Linux Foundation?
Okay, a little about myself. My name is Ajit Singh Raina, and I'm working in Dell EMC. I have been a part of a team, Global Solution Engineering, and we work with the businesses who basically supports the non-supported stuff. So if you are using a Dell system and you want to build up a solution which Dell doesn't support, so I might be the right person because I'm leading this team in BDC, and we have 4 or 5 folks who are in Austin. So apart from that, I have spent a considerable amount of time with Docker in the last 3 years. I'm a part of our Docker Captains program from last 2 years, and we basically, talk in the meetups about the new releases which comes and new features, blogging. Sometimes we work very closely with the developers to contribute for a particular project, just like I contributed for Linux Kit. So I was earlier in the VMware in Kalyani Magnum for 1.5 years, working in guest VMQA team. I was testing a guest operating system on top of ESXi 4.1 and 5. And before that, I was in Logica CMG. Right now, it is CGI. And these are my handles, Twitter handles, and LinkedIn. You can follow me on. Okay, so this is going to be an agenda. In the last meetup, I talked about Linux Kit DockerCon announcement, which happened where the Linux Docker platform is going to support Kubernetes along with this Docker Swarm. I'm going to talk about that, and then current status of Docker for Mac, because I've spent considerable amount of time. I have written around 4 blogs. My website name is collabnix.com. I'll share at the end of the slide, where I'm going to show you what is today supported, what different platforms support today. And then I'm going to show you a demo with Swarm and Kubernetes working together, and how I will show you a showcase about it, and then a quick demo about the context switching, creating the application, and how it looks like in the Swarm and the Kubernetes. Okay, so let's start it. Let's get started about the Kubernetes supported Docker platform. There are 2 editions, Enterprise and Community. In the Community edition, we have a Docker for Mac and Docker for Windows. Starting from 17.12 plus beta, you will have, if you are running any Docker for Mac version before that, you won't be able to see that Kubernetes has been included. So you can see there when you open a reference span, you can see that the Kubernetes version. So as of today, 1.19 is supported, and still it is in beta version. So beta release. So if you are using the stable release of Docker for Mac, you are not going to get Kubernetes on top of that. And in Docker for Windows, it is 18.02, and again, it is same the beta version. We don't have a stable release where the Kubernetes has been included.
Right. It will be. It will be.
It will be, yeah.
It will be.
It will come maybe like in a month. And in the enterprise version, yes, in EE 2.0 beta, so they have included it. So I've highlighted few of the points here. So Kubernetes available under Docker for Mac 17.12 CEH and higher. As of now, it is only available in the Edge release, but not included in the stable release. It might come in the month of March. Just today morning, there is a release of 18.02 Community Edition. So the beauty of this release is you don't have to install Kubernetes. So now, one of the problem which the Docker team they are going to solve is like Kubernetes has been very robust, and the community believes, the common belief is that the most powerful distribution or software has to be complex. That is completely wrong. It has to be simple, and Docker is here to simplify it. You have been spending a lot of time setting the Kubernetes up, understanding this concept, right? So when you say no need of install Kubernetes, means it comes out of the box. It's just installed there. You just have to use it, just like a Swarm. Swarm came integrated with Docker, and you just install it, right? You just initialize a Swarm, and the cluster gets started. So it, as of now, it includes a standalone Kubernetes, like a one single node. So how many of you actually use the Minikube? Okay, so it is very similar to that, but you will find that this is more, more interesting than Minikube. Slowly, I will show you the demo on that. So, and the Kubernetes servers runs within a Docker containers. Now, Kubernetes is running inside a Docker container by default. So, first time when you install, don't get scared, because based on your internet speed, it is going to take time. So, don't go to the GitHub repo and raise an issue. So, you have to wait for around 20 minutes, at least 20 minutes. Now, they might improve that, but you have to wait for 20 to 30 minutes, because it is downloading a lot of images from the Google Cloud, and so I will show you a demo on that. So now to switch from one orchestrator to another, you just have a Docker orchestrator variable where you can just set it up Swarm if you want to use Swarm and the Kubernetes. Okay, so this is one thing which new stuff which Docker has implemented. We call it as a stack API controller. So this will be a common flow. You will use a same Docker compose, and you might be familiar of this command, Docker stack deploy, to deploy the stack on the multiple nodes on a single node. Now, when you run this command, it will basically use an API controller which is not yet open source by Docker, and this is an API which it uses. And now from there, what happens is this API controller basically converts your services into the objects, which are like pod services, and you have a so use this particular controller. So all it is doing is it is using this API controller, which is called as a stack, and it will basically convert the services which is created by the Docker stack deployed to the Kubernetes objects. So custom API server has been introduced by Docker, which is called as compose.docker.com, and this API is in charge of keeping your stack up and running. And internally, what it does, it converts your services into the objects and maintain them. And still, it is not open source. It watches for the stacks and create an update corresponding Kubernetes objects, deployment services. These are basically the terms. If you are new to Kubernetes, just like me, maybe you have to be familiar with all these terms. And the controller basically watches that, and when any services goes down, again it will ensure that it comes up well. So I'm going to show you most of the stuff in the demo. And what they have done is they have introduced a new command called as kubectl get stacks, which is very similar to like Docker stack analysis. And you can do a lot of things like deployment, updates, rollback, all these things are supported. So demo time, and I'm going to show you about how to enable Kubernetes. Like since it takes a lot of time, actually, I have just show you how the Docker and Kubernetes do while they're running together, and how the Kubernetes and Swarm in action together. I have a few of the applications which I'm going to show you, and then concepts of namespace, context switching. You might be switching between the virtual cluster, right? So how easy Docker makes it to switch the context from one virtual cluster to another. So this is my Mac machine. You see here, I have a Docker version. It's pretty much work. And if you look at the orchestrator, this is basically how it looks like. Your orchestration by default. Since I have enabled it, it is showing like that. So if you see here, the Docker is running and Kubernetes is also running here. The first time when you run it, as I said, it will take a little time based on your internet speed. So if I say about Docker, it shows like, okay, this morning it has come. I haven't updated this, but you can see that it comes with Compose, Machine, Engine 1802, and the Kubernetes. So right now, if you update it, 1.9 is what you can see. So if you go to the preference, when you install it, at the point of time, this is something which has been introduced. You have the preference pane, you will see the Kubernetes there. And if you click on it, you just have to click on this enable Kubernetes. There is one more option called show container system containers. What it says, like you can use the same Docker command. So they have made it so easy. So it is easy for or the operations team who comes from the Swarm, who heavily uses the Swarm, so they don't have to learn any new command. So with by default out of the box. If you look here, these namespace contain queue here, and this namespace will be there in your environments. And then I have GKE, is some of the nodes which is running in the Google virtual cluster is minikube, which I am going to start. This is document from the Docker release. And so is, if you see the command like changing the namespace, so kubectl, you say context, and you see the content. If you want to then go and set it, so you just go here and toggle it. Okay, let's move to the application. Window is open. So let's start with the Docker Compose file. So this is my Docker Compose file, a very basic front end and back end. I have a web and a DB, and web has to open in 8082, right? So the usual process, what I'm going to do here is Docker stack deploy. And I say stack 1. So it shows that both the services has one container running because I have declared that one replica of that particular stuff has to run. And if I am a Swarm user, I can see that I have the stack ready. If I want to see the services, I can see them. So one replica of both the services are running. So what do you expect to happen now? Your Kubernetes cluster is up and running. What I did, I ran the Swarm command, but I have a pods and everything's available. If I do okay, see. Sorry. So page is up. So I ran the same Swarm command. I don't have to learn anything new in the Kubernetes apart from the concepts like pods. So pods, deployment, and services. But for me, everything is exposed. If you do it with Kubernetes, just imagine that you first have to install the Kubernetes, and then you have to basically build a deployment file. On top of that, you have to enter all the pods and all the definitions. But I did it with a simple Docker Swarm, right? Still using the Swarm commands. Okay.
Ajay,
Yeah.
what is the, when you move this to production, the same workflow?
Yeah. So Nipendra has one slide where he has shown like how to move from a dev to production, right?
You just change the context of that image. You change the context and deploy there. Just change the context, that's all.
Manifest and all will be.
Because now context, now, can you open the config file which is there? .cube config file, Ajit. Can you open the config file? .cube in your home directory. Cube config. Yeah. So come down. So search for context. Search for context. And file. Or less, maybe you can do less.
How to do
Less.
Yeah.
Less space.
Less space.
Less space.
No, don't do grab. Don't do grab.
Just do a less. So
Just do less of that file. Don't grab.
Okay.
Don't do grab. Search for context
/
context. So now if you look at here, there's something called as current context at the bottom, right? Current context that decides what context should be used for deployment.
So just change the context.
So yeah, so what he showed in the GUI, right?
Yeah.
So if he changes something there,
Yeah.
current context will change accordingly.
Okay.
So productions will have a production queue and ops,
Yes.
whatever you choose, and when you run the
Yeah.
So
So
what
I
about
have a,
namespace? We are giving a namespace that we are deploying, right? In Kubernetes.
So that's fine. That's fine.
So
So
namespace will be changed, right?
no, so the user is different. So
it's just like you develop something, you test it, and then you move it to the production. I'm not going to attach this node to the
this is
production
the
environment.
this is the cluster. After cluster will come the namespace. So namespace is separate part.
If you can mute your speaker, probably that. Thanks.
So if you see here, so I have these services, right? In the same way, I have a kubectl that particular service which is running, and it has already published it. So when you do a Kubernetes, right, you have to expose the code, right? That has been already taken care by Docker Compose. Now this was while I was doing I use the same stack command to deploy the Kubernetes cluster. Now let's do one thing. So I changed the orchestrator, switched on to Swarm. So if you're familiar with this, it's already into the Swarm. So if you see the going forward, we have already a Swarm on Docker for Mac runs on Linux kit. So that's why you are able to see the Linux kit. And it's coming from the HTML. So I'm going to do Docker stack, deploy, Docker compose, and let me do the same stuff. Maybe check because you have to ensure that the port should be the same. So say in Swarm, I taken web application where I have a port list. The only difference is I have a 5 replicas running, and now I'm showing a purely a kind of a Swarm cluster. So this is nothing which is. So since I'm running on Swarm, it should not basically contradict with the Kubernetes. And it says stack free. So it will go ahead and build a stack, and this will be purely on Swarm.
Can I have both the things in same cluster? Kubernetes plus Swarm.
Kubernetes, you can use a Swarm CLI, but you can't have both. Because that will again look the orchestrator what how they have done because there will be a the resource usage, right? Kubernetes is one orchestrator, the other is one orchestrator. You can probably run it in the testing environment, but not on the production environment. Production environment because the Swarm will reserve some of the CPU and memory, right? And again, the Kubernetes will again reserve a different code. But it should not, the code should not, contradict each other. You can probably run that. But for production environment, it is not. Environment, you only one orchestrator. This is just for a testing environment. If you want to test it some application, right?
to change the port probably.
Yeah.
It's conflict.
So it's conflicting, that's why it is.
Hello. I'm not sure. Between today's phone performed. Happened over this break meeting room.
Go ahead. Yeah, I picked up the other one. So this is one more application which is there. So the whole idea is like I just switched on to the Swarm and I deployed an application. Now it should be up right now. And let me show you the other aspect of this. So if I go to the Kubernetes and say if I pick up any of them like Minikube, and say don't try to run here the Docker stack because now I have changed the context. If you run Docker stack deploy, it is going to stuck in between. I say start. So this is going to start. VM. And now it's basically use the cryo, right? That runtime. And now I have changed the context and I've started the Minikube. It is going to deploy, use the virtual box and deploy one of the VM. And now I am into the different context.
What is the context actually?
Context is a namespace concept. If you see in Docker, we have a concept of namespace where your application has to be isolated. So you have a virtual concept of virtual clusters. And at one point of time, I can have a 3 namespace, which could be a production, QA, and all. I can do some of the testing or development work in a development, and then move to the other namespace, right?
So I think his question is context, right? So context is different. Context is different. So context just means that on which cluster you are connected to right now. Suppose I have a cluster on like Minikube is a one cluster. I have one cluster on Amazon. I have one cluster on AWS. So there are 3 different clusters.
They can also run on the same VM.
Not VMs. I'm just saying that assuming that you have 3 clusters running on locally, running on AWS, running on Azure, or wherever it is. Now, how would you tell which particular environment I should go and run my application? Correct? That is called context. So if you open the, can I come over there?
Yeah.
Let me just. So the idea is that if you look at this one. So if you look at this config file, I'm going to so here is the config file. Look at this config file, a couple of sections. This is called clusters. In the cluster 1, I have a section called localhost. Second cluster is running on some IP, which is like a local host on this IP. So I have a section called clusters, in which I define multiple clusters. That cluster is running this IP address. This is the certificate by which I can connect to. So I have multiple clusters I can connect to. Think about Azure is a cluster, AWS is a cluster, different clusters. So these are my context. This is my cluster name. And then I have, at the bottom, I have these users. This is my one user, like name, user, what is the user certificate for that? And then there's another user, Kubernetes admin, there's GCP users. So I have different users. So I have different clusters, I have different users. In the context, I connect a cluster with the context, a cluster with the user. So if you look at the context section, you would find a context in which I am connecting a cluster with a user. That is my context. So here I am saying that with the context name Minikube, I am connecting a cluster called Minikube with a user called Minikube. With the context of Kubernetes admin at Kubernetes. I'm connecting the cluster Kubernetes with user this one. So I have multiple clusters. I have multiple users. Depending on the context I choose, I'm going to hit to a respective Kubernetes cluster. So if you look at this file here, or one more command, kubectl config get context. So this same thing what will come in for Docker format, right? What was coming there, right? The same as these names. Docker for desktop, Google Cloud, Minikube. They are the same clusters. What context I can see from there, right? They are same context. So when I change my context, the respective would change. So let's assume that if I change my Kubernetes admin to admin, so what happens is beneath the scene is going to change the current context. So I have multiple contexts, but in the current context, I decide which one to connect to. Yeah, this is the current. So I have changed to Kubernetes admin. Now if I go back again there, and if I make it to Minikube, you will see that my context is now changed to current context changed to Minikube. So which means now what happens is this kubectl binary. This binary what we have, it is being configured to look at that config file and decide what to do next. So with the kubectl is a CLI. That CLI has to connect to some cluster, and that is only coming from that config file. Okay.
Basically, it stores all the credentials.
Correct. All it is in there. So when I run this command, right, now it knows that I need to go to the Minikube.
The username, password, and
Yeah.
API token.
That's means for the config file. So the kubectl binary is configured to look at that file, right? So I should have that file. So assume that if I move that file somewhere else, right, I'm going to take a backup of that. So it will not work because keyboard size. Not back, right? So now nothing would work because there is no config file, right? So what I could do is I can either put that file back again, or I can say export kube config, I think single word, kube config is equal to, sorry. Okay, I just made that thing. So if we export a kube config one variable, that's also fine. So let's just get back towards the, and then continue. I think that is clear right now.
How much time I have?
So you have time because one of our speakers is not coming, so you have time. So we'll take a break after that and then.
Okay, fine. So we have just done the Minikube. So as of now, we are able to do it, right? So I can probably go there and run Minikube dashboard.
Ajit, a bit louder.
Louder?
Yeah. Well, the voice is not coming in the videos.
So I can start the Minikube dashboard. It is like a fancy UI where you can see all the namespaces and nodes, persistent volumes. So the whole idea is like we are in a different namespace now, or context now, and then we are working on the Minikube. At the same time, I can go ahead and switch back to Docker for desktop. So when you do it, when you start using Docker for Mac or install it, ensure that Docker for desktop is selected so that you can use both Swarm and the Kubernetes. In the same way, if you see, I can switch to particular Google Cloud context, and then I can display my nodes, or I can work in that. So as of now, it shows like both the stacks are up. I can also see the services around it. So pick up this me see if this application comes. Sure. $80.85. Let me see what application is this. So this is one application which was shown in DockerCon, where you have a front end, back end, and there is one API for words. Randomly, you will see that the words come from there.
The local host spelling was misspelled.
Oh, that's right.
Just come back. Reset.
Okay.
No, on the terminal. On the terminal. Tell you, expose the port. No? This local host is misspelled actually.
Okay.
So, but the terminal is open the browser, right? You don't need to.
Yeah.
You don't need to go back.
Yeah. No. Okay, it's local host. Yeah. This is fine. I think that's yeah. Yeah. Correct. Yeah, open command does that.
Yeah. So the whole idea is like in between we switch back to it. So this is an application which, if you go to the Docker for Mac official page, this is an application which they have showcased where they are saying like, okay, the same application you can run through the Swarm CLI that gives to the Kubernetes. Right? So now the same functionality you can test it on Docker for Windows also, where you can have both Swarm and Kubernetes. I tried with EE version where you have to install Kutl, and then you have to just install that, and they have introduced, if you are a beta user, if someone has registered for the beta version of EE, you will have access to that. And that goes to, if you want to try it out, it is in Play with Docker. So how many of you have heard about Play with Docker? So Play with Docker is a playground where you just go and play hyphen with hyphen Docker, and you get a kind of a fancy kind of a UI where you can just go ahead and add the nodes and set up your Swarm cluster as well as the Kubernetes. So we have Play with Kubernetes, Play with Docker. You can use that. So this is one example which I have given. Other than that, if you see, there are a couple of other things which I haven't tried it out. In secure registry, there are certain issues. I don't know, today I have to try with the new build where they have fixed it. So in secure registry, if you want to run your private registry, you can go ahead and add to it. And then what are the images you have been using for the Kubernetes, it will pull from the private registry. And the registry mirror, if you have registry running, if you want to mirror the registry from one server to another, or in between the mirroring part, that is taking care of that. And if you are doing a kind of insecure registry, you first have to share that particular folder here, which you can add it, and then you have a registry container which can run on 5000 port, and that should work. Other than that, there has been a few issues which has been reported for high CPU and memory utilization, and that issue is still not fixed. And just be aware of that when you are running for Docker from Mac, it is going to consume high CPU, and your battery is going to die soon. Because now they haven't fixed it. That is one issue if you go to the GitHub repo. So since it is in a beta release, you can expect few of the things doesn't work out because it's beta release, right? You can't expect everything to work. But if you are using a Kubernetes or you are a Swarm user, you will see that it becomes very easy. You just have to be aware of what are the new concepts with the Kubernetes and all, because since it's the latest Kubernetes version which comes with it. So do expect that if you are a Swarm user, you have to be aware of what are the Kubernetes objects are. So that is something which I recently started. Right, it's not like 1 month I started with the Kubernetes, and it becomes very important. But if you are a Swarm user, as of now, you can use the same CRI to bring up the Kubernetes cluster. So I think I'm pretty much done. Any questions? So this I have already put it. This is my website. You can say gulabis.com. Categories Kubernetes. So I've written around 5 blogs on Kubernetes and Swarm together, and I've given an example so that you can visit it, and you can expect more contents out of Kubernetes now, because that is where the industry is focusing more. So most probably the next blog will be on Docker for Windows, how to use it, so that you will find it very easy to use, be aware of the Kubernetes concepts. Any questions?
Context of will be shown.
Yeah.
Right. So let's say the cluster. Definition for setting up cluster. Let's say I can choose from the Docker or kubectl or any. So I just want to see like which all parameters I have to give there to set up the my own cluster.
So you don't primarily have to go to the config file. That is one way, but you have a kubectl get config, set config, right? You can use that. You don't have to go inside and
You can write down one shell script which will make easy to execute in the clusters.
clusters. So you're talking about you want to create your own context.
Yes.
Context and all. Then you have to. I'm not aware.
Yes, that can be done. You can customize it. You can use aliases for the cluster URL, and that would be easy to switch between the clusters.
I haven't tried that actually. If you are heavily using Kubernetes, I think that is one part you might be doing it.
So my use case is to define a cluster for each of the app based on the regions.
So yeah, you can set it up. You can create it. So you can, if you go to the kubectl config -help, you will see all the commands are there. Section of commands.
So question I think you have. Oh, sorry. Question. Can you repeat the question again?
So let's say I have the app and which is on different cluster. Let's say I have 5 apps which runs on 5 different cluster. But for that I want to set up the config file.
What config file?
Cluster setup.
New context. New context.
Context of what to do with 5 different clusters?
Yeah.
What do you do with the 5 different clusters?
Let's say for each customer it is separate.
No. So you want to just partition your customer to in each cluster, or in one cluster you want to have 5 partitions, right?
No, he's running his application in 3 different clusters. INT, within prod, switch between those. Using that.
So segregation.
Yes.
No.
This is set cluster.
So question is not clear actually. So like trying to say, you can have 3 clusters, 5 clusters you have, and you right, separate your 5 different clusters.
Customer specific. Let's say
Yeah, so 5 different applications, 4 different customers. One application customer specific on 5 clusters. Now what?
so I define this when I want to apply or run the commands for particular customer set to start.
Correct.
The customer one I define in the config.
Right.
So in the telling me how we can use let's in the different set of
Need for context, you just 3 things. You just need the cluster and the credentials. The second thing is the user which will connect to it, and then you would just connect the cluster with the username. That's all. We don't have one of our speaker is not coming. So if we have time, I can create one of those things. So okay, anything for? Do we have Shubham here? Shubham. So we're going to have 2 speakers now. Hopefully, he'll reply back. So anyway, let's take a break for now, and I'll see what we can do with the remaining time. So we have Vishwas here. So post a break of 15 minutes, we'll start with Vishwas, and then we'll see what we make the rest time.
There's tea and coffee on the right side. Questions are on the left.
Question right now I'm facing in the application. I have 5 microservices.
Right.
Okay. One is for accountable something. Then I deploy in the Kubernetes. So when I have a 3 environment, production, test, or dev. So when I need to change the namespace when I'm deploying Kubernetes. Suppose one application is in production, all are in production, but I am changing only one microservices. So to deploy this, it should be in 3 namespace, dev or trial or thing. So when my application is in dev and the other are already in like prod, so to coming in prod, all the connection will be breakdown, right, for the microservices. So how can I achieve this for namespace one?
No. First of all, application can talk across the
It's a
network.
one application, under the one application, I have microservices,
But
right?
understand. So how you are exposing it to the outside world? You are exposing only production to the outside world, right?
Yeah, production one.
Yeah.
So suppose four in production, so other one is coming. We changes something microservices. Okay, so now it came to first is dev, then trial, then it come to production. So when it's coming to production, the breakdown will be breaks, right?
What breaks?
The application will break when I'm changing it.
What break? What do you mean break?
No, this is
Is the connection drop? You saying
Yeah,
that?
yeah,
No.
yeah.
So you can multiple strategies out there. There are strategies like rolling up things. There will not be current problem. There will not be any update. There will not be any delay at all.
so namespace is different, right?
So what I say that you have half-baked knowledge of Kubernetes.
Huh, okay.
Don't mind it.
Yeah, yeah.
What you do is you take my course on edX, edX.org.
Okay.
Search for Kubernetes. There's a free course available for that. Take that course, complete it. It's like you take one of the
Which
edX.org.
that's
EDX.
EDX.
EDX.org.
Okay.
That's a free course. You can take that course, and then we can talk. Because I think the communication gap is there because
Yeah.
no, just take it. Don't take it as a right.
Okay,
Just spend the time for like few hours.
Okay.
Review that thing and we'll talk on the same. Okay, I'll give you the link.
Have you ever tried deploying Kubernetes on bare metal?
Yeah.
Like I had a huge problem while getting the certification issue. I tried to deploy it, but I was not
Use
able.
QBDM. QBDM will do.
But Kubernetes, like you, if your distribution is it's not supporting Kubernetes, like you're having 14, which 14 doesn't support Kubernetes, right?
Okay.
So I got stuck in that one.
Okay.
So when I deploy multi-cluster,
But why are you using this one? Why are you using that one?
14,
I will study
like
that.
I'm bound by customer,
Okay.
whatever they have given. So I cannot use Codex also.
Okay.
So
And then you'll have some tough time with it for sure.
yeah, I am already having tough time. Like, are you having any tutorial or something like that for that? Bare
But I
metal?
don't have for 14.0. I haven't tried that. 16.0 what I have been trying with QBDM.
Like QDM is pretty easy to deploy.
Yeah, that's all.
If it is a restricted environment, you don't have any internet connection. Day
Correct,
one.
correct. So we have to have the previous packages and everything downloaded and then do that. So Ubuntu, you want Ubuntu 14.0 only? You can't do anything else?
No. Like think like that is very restricted environment.
Okay.
So everything is locked up and you cannot do anything. So you have to.
So then you look for some of the Ansible scripts which are available.
Yeah, Ansible scripts I look for, but I want to know how these things, internet things are going on without directly using the Ansible script.
Okay.
I thought of like going how it's everything, this flow is going.
Okay. Yeah, so there is I told you that edX course is there. I'll give you the link now. You can take that, and I also train people around that, so you can talk about that.
Where is the best place to start? You build your own OS. This is all about learning.
Okay, we will talk about for everybody. We'll talk with questions. So basically, you don't have a speaker, so you have a lot of confusing answers. You raise a question there, and then I'll respond to everybody.
Suppose I work for them.
Yeah, that's it.
Take my own OS.
Yeah,
The customer will say, okay, I use OS. Okay. With the Ubuntu
this application requires distribution as well as
and then you build it on top of that.
let's what about the code OS right now I just need normal security and there is a process, so it's a deep learning model. And whenever there's a query which comes, we need to
Look,
create
this is the best, yeah, so correct, I got the point. So there's something called auto scaling. So you need to tweak some of the Kubernetes
All
API
the
level.
products, right? All of
So
the
that you can listen back and perform. So there's already there. What I suggest to customers go to Kubernetes Slack channels. Ask
The code is very simple. You take a DNA,
They would the right notes to answer.
So it will be, so the, as I am assuming that when there is a query when I need a GPU,
Usually,
then
So you need
Whatever
to kind of trigger somehow.
that is
You know, saying that if that happens, you need to have a trigger. That
which
trigger
will
can do that, yeah.
spin up the image and then.
But you need to kind of find it's not coming out of the box. You need to kind of, but you can tweak that. Just I'm saying
And
that.
how much time will it take to actually come, make the instance live and start?
very minimal.
Depending on the cloud environment also. Right? I think we're talking about cloud.
Yeah.
Docker full open.
Yes. So depending on how much the cloud would take.
So if I
Depending on, I
want
think,
something
what
very
is not
small,
taking more
there
than
might
5
be
minutes.
something like
Less than that.
Less
Less than that also. What you might think you can have a pretty big AMI users also, which you can build, right? So we can start from there.
Okay,
That's
just
also
spin
there.
up that.
Yeah.
And is there any other alternative like instead of Kubernetes, maybe Sage
Take one Redmi,
Sage
AWS.
200 MB is also okay. I would say
No,
it's
no,
okay. It's
no.
not like a Windows. Windows is like a 9
Windows,
GB, 10 GB.
But
They are dependent on
ECS right now. But yeah, look for custom metrics scaling. There's a keyword there on Google and ask the question in the Slack channel.
So if I want to use Python, I don't have to go to install Python. I can just directly put Python -Alpine, and that is like a 20. I will get a whole Python.
See, Alpine is
So don't put on the base over it. Put the application itself.
When you want auto like a feature like fault tolerance, auto scaling, like when a load comes, I can see another number of containers.
Why don't you develop
For that, I'll
no, so you
Make
take the
Alpine.
composer, change the code and recreate.
run an application multiple loads.
Take Alpine and install Python and then build an image.
Because one node goes down, everything is
Why you
gone.
have to now if you go to Docker scaling Python,
Multiple things. So again, I told you about it. TEDx was a mistake. I'll talk about
I'm not
it.
And they'll have extra packages.
So if I'm high deploying with people not Red Hat, then I can't directly own Alpine, right? I have to depend on Alpine for Red Hat because the customers are users and for the clients. Yeah, we'll try to make
I just have
and another VM we are hosting on Kubernetes. We have a Docker. So right now, see what are the other VMs? They have a DCA component over there in the that require more consumption of resources, right? So right now, other VM where we're installing Kubernetes, all the pods or component getting installed. It's required. I don't have resources right now. So one component I want to install on another machine. So we have one Kubernetes single over there. Another machine
just single one, right? You can't
that puts
extend
the
it.
DCA,
I say
whatever.
like this mini cube which I have developed
Hardware you can link it
time,
twice. Hardware if you can
second
link
node
it,
for
you
the
can make a
node
hardware
should
panel.
be usable.
They are part of the-
We're not going to extend it. That is just
It
for
can be
user.
different cluster, right?
Some
We can't host it. Some of the VMs is hosting on this machine, some of the VMs like
Limited to one
VMs
laptop.
is hosting on another
Or one
machine.
machine.
So for Ranches,
So
if you can have a two
Cluster of
Kubernetes
nodes
clusters and
and
one
one
Kubernetes cluster, maybe pods. So inside that a lot of pods will be there. Because we have a free pods. Kubernetes
So as of now,
suppose
the
pods.
Only one. No, again, same thing like a virtual you are forced to use it.
mini cube is supposed to be certified Docker from own technology.
Just because it doesn't support
Okay.
is it the same with
No. If suppose we are installing some VMs on another machine, we can make
You
it
need some
similar cluster.
some
You are
environment.
outside.
Just get the URL, put in your pod, will you access it, right?
So Ubuntu doesn't use
matter,
Docker
right?
for
We-
massive,
we
it doesn't
can
use
use
it. Okay. It uses its own technology which Docker has developed.
Something like it, yeah.
In Windows they use Hyper-V.
Maybe Hyper-V or virtual.
But wherever the virtualization concept comes top now, there will be a performance bottleneck.
I just put it on you guys said it. It's said yes, yes. Nothing to use on
Where you are running this? following your steps like that, results are there. Then start running. Not really the process you're not able to I've installed my app to Kubernetes not working.
Okay, how do I?
Just okay, you translate. Now you have to wait for 20 more minutes. Okay, which version is it?
Oh, you have to have it.
You have to go to the
Okay. So if I install it, then Kubernetes. Oh, that's a new enhancement they added.
It's only on Edge, not on stable. That is the first slide.
Okay. I mean, like I came this late.
Yeah.
So I missed certain things. Too.
You can follow my blogs also. Okay.
Sure. Thank you. Let's say one GPU, which I can also compared to your CPU. And when I say Docker,
Either Docker found through Kubernetes admin CLI through, either through important. someone talked with the whole that's hiding artifacts, but that does not mean whatever default you get is what you want.
Yeah, of course.
That's even within this, that's the area what's behind abstraction. So the network doesn't make virtualize some of the experiences. Yeah, so we work so right now, these are generic let's we start then they said yes, it was blocked. But it was not intentionally. Our path okay. Indoor it might take 2 weeks more to leaves carrying. Nicolas You're beating
Most likely. Whenever you find I'm not getting the problem.
Okay. Sit down.
You want to use the hand? If you want to use this one. If you want to use, otherwise you can speak a bit louder.
Okay. Just tell me if I want.
No, just ask everybody in the back.
The guy in the back.
No.
Hello.
Hello. Is it better?
Yeah.
Okay. I'm not going to talk about, some bit of an intro about who we are. I manage the engineering team for a company called Linus Networks. And we are a startup, we're a small company, around 15 people. Most of the engineering is done in Bangalore. And so primarily we are a cloud networking company. So what I mean by that is we solve some networking problems using cloud. Okay, we are not solving problems for the cloud. We are using cloud to solve some networking problems. This is akin to, if you have heard the term SDN, SD-WAN. Most of these things are marketing words, and they mean exactly something totally different than the product comes out. We don't use the term SDN, but if you want to kind of think what we do, it's like whatever Cisco does today, Cisco Juniper, using physical controllers, we build that in software on the cloud and kind of solve the networking problem from that perspective. Rather than building firmware tightly closed systems, we try to build an open system. Right? Some of the technology space. Okay, before I go into this, I'm not going to talk about how you can use Kubernetes or how you can use Docker in different ways, how you can run it on your laptop, or how to go from dev to production, right? So these are the topics for people who want to learn Kubernetes, deploy Kubernetes, and things like that. So I'm not an expert on that. The subject just came to my mind when Jitendra said, what do you want to talk about? I said, we have been building this for around 2 years, and we kind of know what not to do on Kubernetes. Okay, and so I thought, okay, let people know what we shouldn't do, especially in the networking space when using Kubernetes, right? So this is not a broad what not to do. In the limited space of what they have used, and we have quite a bit of experience. And you can see the space that we use currently. Um, Even though rocket adoption is not that good, CoreOS has had a good adoption, and primarily around etcd. If folks who have not explored etcd and used Kafka or Zookeeper for that matter, can go and explore etcd. It's a nice tool to understand how to do distributed key store. And we use Kafka, shouldn't forget Linux when we talk about all these things, right? We use Docker and Kubernetes. Then, of course, Elastic Stack for debugging. We are a fan of Golang. The whole company writes all the code in Golang. We primarily use Google, but we have been using AWS as well. So we want to be as heterogeneous as possible when it comes to cloud. Somebody's taking pictures. Okay. Okay, so how many of you know Peter Diamond is? Okay, so if you guys don't know, just go search for him. People know Google Lunar X Prize, right? Some Indian company, Indus, right? They had a ISRO pact to send a spaceship to Moon. So he is the founder of a lot of X Prize competitions. He is the founder of a university called Singular University, and it's an amazing university. So he's kind of one of the all-time person in the US who encourages innovation, right? So his term is. So when I made this headline, I was thinking, am I the right person to say what we shouldn't do on Kubernetes? So what he's saying here is only an expert can say what you shouldn't do, right? Everybody can say how we can run this, how we can do that. If somebody tells you shouldn't do this on this particular platform, and if it is right, obviously, he is an expert. Because it takes time for you to know what you shouldn't do, right? So I'm not claiming to be an expert. I'm just going to say what we have done. So this is what we built, okay, at a very high level. So we have our devices, and we build a global controller, microservice-based controller. So a typical Cisco box would have your line cards, right? Those of you who have ever gone into data center, you would see, layer 3 router or something like that, refrigerator size space, and you have line cards. And top of that line card or in between somewhere, you will have two things which would say controller, or it will have fewer LEDs than the line cards. So these things are controllers. Basically, this is where you write code. When you type Cisco CLI, that's where your CLI is running. And these heads or controllers are not doing anything 99.9% of the time. So they configured those line cards and they're done with it. After that, they're just sitting idle for something wrong to happen, or something to happen which is not configured. Right? For example, you would say, okay, this packet should go from A to B, but a packet from C comes, it does not know. Only then line card wakes up. If A and B, sorry, not line card, controller. So if A and B are talking for years together, line card has nothing to do. But if you need a feature that changes the communication between A and B, you need to ask Cisco. And based on how much money is in your pocket, Cisco may say this is available this year or in the next decade, right? So the point of SDN is to make it open source. So to make the controller available in such a way that it's plug and play, you need a slight change in behavior. You can go write your own plugin and change this behavior. Now, this term was used for last 4 or 5 years. What has happened is everybody has jumped onto the bandwagon. They said, my product is SDN, right? Without changing anything sometimes. It's become a marketing tool. So why are we doing it? We are a startup. We have nothing to gain by doing just marketing. So we realized that when you build switches or routers like this, the cost is too high for the end user, because the thing that is most expensive in that is the controller, and it is sitting and not doing anything 99% of the time. Even if you don't go by this marketing bandwagon, if we can take the controller out, make it cheaper for everybody, can we sell it cheaper? So that's the business idea, right? So now I'll stop talking about what we do and come back to how we do it. So beside, okay, so we need a model where people can come in and write their own modules and change the behavior. What's the right way to do it? So there are open source SDN controllers. Open Daylight is one. You can go and explore it. One of the key problems open source controllers are not building is really useful for the enterprise. Okay? To make it really useful for the enterprise, it needs to scale. It needs to have security. It needs to have high availability, right? And it should be, by today's standard, implementable either in-house or on the cloud, depending on your choice. Open source controllers are treating it as a controller problem. They're not looking at how the end customer will actually deploy. So we took a call around 2.5 years ago, saying we want to go the microservice way. And when we go the microservice way, you can come and write your own microservices. We will expose the interface. That's the way to go. And it turns out Kubernetes is the best platform to do microservices today. The other platform, which I'm not aware of my experience and what we started building, we quickly tried finding, we found examples of how to do it. When we tried doing it, it worked. That basically told us, okay, that's the right way to go. So all of the top checkbox items for the enterprise were available in Kubernetes. Okay, so I'm going to concentrate more on Kubernetes, not so much on Docker, because
You mentioned few problems like this as
scalability, HA, security.
But those are not there in OpenStack. So
no, so OpenStack is not a SDN platform. So OpenStack is OpenStack has grown and become really big. It is not tailor-made just for SDN. So in other words, it has become a data center management platform now. So we wanted to be very specific with respect to network SDN. Okay, so not get into whole data center. OpenStack, you can do everything, but then it becomes too complicated for an ISP to run it. You get my point? So it's become bigger than what a typical SDN end customer wants. Okay, and on top of that, we need to be able to give it within some cost constraints. So to run an OpenStack with the same level of feature set, you need much more resources. One of the other reasons why we went to Kubernetes and Docker is, and our Golang as a primary reason for developing is we can use really less resources for doing it. If we go with options like resource Java, we would be using 4 or 5 times more resources for doing the same thing. It may be easier, it may be more flexible, but it comes at the cost of resources. Okay. So, so I'll jump into this. So I have very few slides, so interrupt me at any point in time and ask what you want to learn or what you want to see. So I'm going to concentrate mostly from networking perspective. So today, our controller runs around 23 services. Most of them are written BAS, right? So, so they are spread across different kind of the primary activity for these services are quite different. So some services would like to get a packet from the internet and give it to a particular microservice that is sitting inside. And some services may want to get a packet from a microservice and give it to another microservice. Some services, like typical web services, may want to respond back with an API request. Some services may want to monitor everything, right? Some services may want to act as health keepers. So they basically are pinging everybody in the world. So I showed about the devices which are there. We want to know the health of all these devices in the world. So depending upon the use case, Kubernetes gives you a set of options, right? So let's say you have a use case where okay, so I talked about we have 20 odd services which are running. Not every, so if you go back to the example where we had this controller which was not doing 99.9% of the time, there was a service which was active all the time. There were a couple of services which were active, but there were around 20 services which were not doing anything. So how would you extrapolate that to your deployment? So that basically means in these 23 services, you have some services which need scale, which are going to be active all the time. But there are some services which don't need scale, which probably are there as a couple of instances just to handle HA, right? So you need to, first of all, break the dependencies between two different services to say, one service should not know how many instances of other services running, right? So that's the Kubernetes default abstraction. But at the same time, when we do networking, the other service, if two services say, okay, I know that there are 3 parts of this other service running, which is by Kubernetes API available. If you do that, then when errors happen, if suddenly it becomes 2 nodes, or if scale-out happens and your 2 nodes now get migrated to completely different node sets, you can't reach these nodes anymore, right? So you can use deployment in services which require scalability, but at the same time, these services should not be talking to each other, right? Within a given service. So I'll give an example. Let's say you want to deploy Kafka, okay? And what happens today is Kafka today assumes that these pods can talk to each other, right? In fact, it's a clustered system. It has to talk to each other. Now, if there is a scale-out event or an error event, the pod moves somewhere else. So the service, one of the nodes which was actually talking to other Kafka, the old IP address, whatever it is, does not work. So in such use cases, you have to do something called stateful set. Okay, so now stateful set, the definition today is very limited in Kubernetes. You can combine stateful set with something called persistent volumes, and say whenever these error events happen, you want that persistent volume to be intact whenever it comes up again somewhere else. So using this, you can, if your state is all in the disk, you can achieve a distributed network scale-out for that particular module, which requires disk-only recovery. Let's say you have cache recovery. Then Kubernetes does not define anything for you as of today. So that is something you might have to break it into 2 services. The cache recovery is an independent service compared to your disk scale-out service, which needs to talk to each other. So you use deployment, then pods don't have to talk to each other. They are independent. They get a request from outside, they do their work and ship it to the next microservice or ship it outside or wherever. But if they have to say, I want to talk to another pod before I need to act on this, then you use deployment. Sorry, you use stateful steps. So that is when Kubernetes gives you a guarantee that the namespace will be intact. So there are some pod names. I think when Ajit was showing, you were seeing in front of that pod, there were a lot of random characters, right? So when you use stateful set, you can define how those characters should come up. And when they crash, come back up, you can say, that's the way I want to see it. I want to see my first Mongo node as Mongo 0, no matter how many times it crashes, no matter where it moves, or if I change the resource requirement of Mongo node 0, it should always come as Mongo node 0. So Mongo node 1, which is talking to Mongo node 0, may lose connectivity with Mongo node 0, but it will always try to connect with Mongo 0. So that's the way you can recover out of error situations. So if you use daemon set deployment where stateful set is required, you're going to face issues, right? So now coming to daemon set, especially when you need to monitor everything at level in each device. Now you're saying you're predicting that with the requirement that now scalable. So the scales down are used. One of the nodes just crashed in hardware. It's not going to come up, maybe for a couple of days. After a couple of days, it comes back up. So how do you monitor these kind of situations? Right? So that means your pod should be running on every node. So if you have a networking use case, or if you have any use case, where you're on every node, of whether that pod is actually a node or not. So usually them is used for monitoring statistics, used for scenario, while some code on that. So this is the high level what options you have, what so now coming back to some deployed pod, let's example an API server hit by the internet and you are running 10. Now which of the pod will come from outside? That's one problem we have. Second, microservices which are talking to so if one microservice, and let's say there is a packet, so most of your forward path should be same as the reverse path. Just the behavior is going to be different. It may work. So how do you say when microservice wants to it uses the part one, I want the response back in the same path. If the response it will work if you design it that way, but the performance is going to be bad. Then okay, I know how many pods exist in this. Okay, I want to address some of this. You can have kind of there's an idea. When I want to, and I want to directly most of the Kubernetes abstraction is you put a load balancer, right? So when you load that, what happens in networking? You put right balancer is now looking at a packet, looks at the destination, figures out which port to send it, may change the source because it needs the packet back, right? Because the destination does not know how to send it back. When it gets the packet back, changes the destination back to source, sends it. So you introduce a hop, you introduce a performance override on each packet. It may be inevitable in some cases, but there may be performance paths in your system where that is not the approach you want to take, right? So if you need microservices talking between them, but you still need a load balancer, that means you want to go through this path, you will use cluster as a service. Usually the term used is cluster IP because you get an IP address and microservices are not supposed to know the IP address, they're just supposed to use the name. When you do name resolution on that, you get one IP. And that IP is basically an IP table magic, which you can figure out if you go deep into how Kubernetes manages all these IP tables. And that when you hit that IP table somehow makes sure that packet reaches that destination. But only microservices, only services within a Kubernetes system can use this. Let's say you need people from outside to hit your service and then get distributed to all the pods you want, but you still need a NAT or a load balancer. That's when you use a load balancer. Okay. So basically, by definition, when you say load balancer, you get an external IP address. And when you get an external IP address, when you hit that external IP address, the load balancer associated with particular service that you're exposing knows exactly which part, how many parts are running, will direct it to one of the pods based on round robin. You configure it. So today it's round robin. There are ways in which you can make it behave slightly differently. So it will choose that, right? Then comes the question: when would I use headless? I don't need a load balancer. So look at this problem, right? You have two microservices. They should not know how many parts are running, but they are not going to go through the load balancer. So how would you achieve this abstraction? So there is no load balancer. There is no name that you can convert into an IP address, but they should not know how many parts are running in each microservice, but they need to talk to each other. So just in network, basically implement a DNS, and in DNS you get a rotated DNS. So every time you say name lookup Kafka 0, you will get Kafka 0 colon. If you say name lookup not Kafka 0, if you say name lookup Kafka, you will get Kafka 0. If another guy does name lookup Kafka, he will get Kafka 1. So if round robin is done in giving you the name, not giving you an IP address. So the microservice one directly connects to Kafka 0 or directly connects to Kafka 1, bypassing the load balancer. So, so the use case where you have pods communicating with each other, you need to combine it with stateful set and headless in most cases. So when you use stateful set and headless, you'll be able to achieve pod-to-pod communication without knowing how many pods exist. You'll be able to achieve communication directly to the pod without going through the load balancer. So this is at a high level of how you should look at every service that you're implementing. You should look at which category you're going to put in, right? These are just the beginning. There are more categories in which you can modify them, but these are most used categories. Yeah.
Sorry, still didn't understand the cluster and load balancer.
So cluster is an internal thing only. It does not give you an external IP address. So load balancer gives you both internal and an external IP address. So let's say you have a service which is not going to be exposed to the outside world. You will use cluster. You have a service that you want to expose both to internal and outside, you will use the load balancer. So load balancer by default gives you a cluster, and maybe there is a way you can disable it. I'm not very sure.
So in particular, the context in which you guys are working on, it is very important that the reverse path is always consistent.
As far as possible. As far as possible. If there are events, it's going to be different, but you don't want the paths to be very different all the time. See, if you have to debug something which is going to dynamically choose a different path, that's going to add more complexity as well. So you need much more consistent paths for each package. Any other questions around this?
So in case you said if there is that DNS is configured in such a way that it resolves the pod names differently, like in round robin fashion or something.
Yes.
So that's the kind of again balancing or load balancing.
Yes, but you're not exposing the IP address. You're not exposing how many pods exist. So there may be 10 pods. You get one entry. You don't know. So you will not going to assume that there are 10 pods. You can't prefer what pod you're going to use. You may get a different pod when you connect next time.
So that selection is just a random, how it is decided?
That can be configured. Usually it is random.
So you mean IP address of pod is not exposed?
Yes.
Only pod name is given because the pod name is consistent.
Yes, pod name is consistent because we use stateful set. That's why you need to combine these two. In fact, there is another complex variant where you write a stateful set you write a service on top of it, and then you write headless on top of the service. So if you do that, you can completely, even avoid the stateful set names being exposed to the service. So, so even when we say DNS should not be, DNS is not exposing, somebody could take Kafka 0 and put it in their cache. Let's say some admin goes and deletes Kafka 0 and brings in Kafka 4. Kafka 0 is no longer there. So somebody cached it. Now that's going to be a problem for that service. Of course, it's a bad design, but you want, as far as possible in ops, you want to avoid these kind of problems, right? So you could write a service which even obfuscates the fact that there is something called Kafka 0, but still achieves this. Okay, so basically you get a cluster IP, the cluster IP then changes into a DNS. So even if you store the cluster IP, that's okay.
And about stateful sets, I mean, what is the advantages for going for stateful sets? I mean, why do we really need it?
So
what is the exact difference between stateful sets and the normal deployments and pods?
Yeah, so normal deployment, the original term for normal deployment was called replication set. So the difference, very high level difference between replication set is deployment is deployment is what you're supposed to use in production. So it maintains the history. You can do upgrade, downgrade, rollout, yeah, all those things. So that's a very high level difference. In a stateful set, you are basically saying my definition of a, so in a deployment you can say start with one node, then you can start scale it up to 5 nodes, then you can bring it back to 3 nodes. There is no there's no constraint that you're putting. Let's say your Kafka is useful only if there are 3 nodes, or etcd is useful only if there are 5 nodes. Anything below that it is not useful at all, right? So first of all, there is the stateful nature of that particular problem, but then on top of that, you are saying don't treat it like the normal scale out, scale in. There are issues involved if you scale out, scale in, just like a deployment, right? So, for example, if the majority requirement in an etcd cluster is 3 nodes in a 5-node etcd cluster, you should never bring it down below 3 nodes, even if an upgrade were to happen. So you can define that in stateful set. Whereas in deployment, it's much more relaxed. You're basically saying bring on one node, bring it back up, bring on another node, bring it back up, things are going to be fine. But stateful set, you can define all these things. Okay, so not every definition is available in Kubernetes today, but it prevents some simple mistakes if you use stateful set.
So one example I can give you, so basically like if you deploy MySQL cluster inside Kubernetes, MySQL cluster requires that each node of MySQL would have a unique host name all the time. So if you deploy as a deployment, then what happens if one of that 3 pods of the deployment dies? The new pod would come for that, but the name would be different. Yes, but if you deploy as a stateful set, if the pod dies out of that 3 pods, the next pod when comes up, it will get the same IP and the same host name. So that the cluster of MySQL is maintained inside the Kubernetes. So when you deploy a cluster of clusters in Kubernetes, you use stateful set in a simple things, you can think like that.
So like, cluster is a very generic term, right? But when we really say something is a cluster, that means they can discover their peers. Only if they are discovering their peers, it's a true cluster. If there is a bunch of things which are just serving requests and not talking to each other, it's still a cluster, but it's not in the true sense. They are not detecting what is the majority. They are not detecting, they're not doing an election per se, right? So if you read about 2 clusters, they have to do elections. They have to do whether they are majority. Let's say they in a 5-node cluster, 3 nodes are lost. They should stop serving the request, because it is possible that 3-node cluster is running somewhere else, and that is taking request. In 2-node cluster, you are taking request. Basically, both requests are going on, and when the merge happens, you basically lose data, right? So all these things, when they are done, that is a true cluster. If you do true cluster inside Kubernetes, you need to take care of it. You can't just deploy it as deployment. It will work till the day it breaks. Okay, so this is just a highlight of what I was saying. So you look at deployment as a stateless replica set management. Okay, so stateful set is a stateful Very high level definition is disk today. People are talking about how do we do it for cache, how do we do it for network and things like that. But as of now, it is disk replica set management. Daemon set is node based. You want it on every node, you can put it in daemon set and every node will run. One problem that you have seen when you do daemon set. So this is a difficult problem to solve even for Kubernetes. So in every pod, if you are running production, you have to say exactly how much resource that guy is going to take. Right? It's end of the day, orchestrator has to put the right pod in the right place. So you say something requires 100 MB memory, 0.1 CPU, right? That is required for every pod. If you don't do it, what Kubernetes will do, it will do a best effort. If it is there, it will do it. Or if somebody higher priority comes, like somebody who has defined a limit and you have not defined a limit in your pod, that guy gets priority, you get kicked out. Right? Now, by definition, daemon set needs to run in every pod. So it's a conflict in resource management. You are saying this pod needs to run on every machine, but it may not have the resources because other pods are asking for more resources. So typically what you're seeing is if you don't do your resource management right, the daemon set may not run because Kubernetes thinks it is the least priority thing. So if you have a really high priority daemon set, there is a different type of replica set that you need to run. For that, today there is no direct option available. So you need to say this is a critical daemon set. It is above my resource requirements of other parts. Because if you have a monitoring framework that has to run on every part, you may end up in situations, especially you don't end up in these situations in the beginning. In the beginning, everything is set up, everybody is happy, everybody got the resources, machine goes down, Kubernetes now has to think where to move these things. Still not a problem because daemon set does not move. That machine is that daemon set is not useful. Now, suddenly somebody executes more services, increase the replica count or something. Now the machine comes back up. Now you have more resources than what you started before the crash. Now Kubernetes decides based on the resource requirement which one I'm going to move out to this new resource, and your daemon sets may be left out. And then that machine is not monitored anymore. Okay, so I'm going to give a small demo around this. So this is, you saw the pod part, then you should deploy what. We also discussed headless versus cluster IP, right? When you use headless, when you use cluster IP versus external IP, when you use that. The third point is something that we understood as we started using Kubernetes, right? So your service is detached from the deployment or stateful set, whatever, right? So you can technically define more services for a given set of pods. So that's not very intuitive to people. Why did the abstraction put service differently and pod separately? Why didn't they mix both of these into one? Why don't you go and deploy your MySQL cluster along with how it should be used? So that's a very nice abstraction where Kubernetes said, okay, you can deploy your MySQL cluster. Now you can define 5 services if you want. One which only gives you access to monitoring data of that microservice. One which gives you read-write data. If you were to separate MySQL into different port numbers and different access control, you can write multiple services. So one of the very nice things you can do is you can bundle set of pods. Pod is by definition a set of containers. So you can bundle set of containers, and you should be careful while bundling because you don't want to bring in dependency. They are there because both 2 or 3 EFTs containers achieve something commonly, right? They need to be in that pod. If you do that, for the same deployment, you can write multiple microservices or multiple service abstractions. So one service abstraction could be load balancer, another service abstraction could be cluster IP. So there are tricky ways we can play. Why it is important in networking? See, if you read about microservices, just because microservices is there, a company should not implement 100 microservices. And then it becomes too much of a headache for ops to manage, and every team is saying my microservice is working fine. It's really a complex problem. So you need to decide what is the right microservice set, right? So when we say microservice is the deployment, not the service definition. Service definition is something ops decide. How do I expose this service to the outside world? So let's say you have a team which has to do something on the lines of OLTP, online transaction processing, when somebody buys something off your website, and there are three teams. One is doing OLTP transaction, one is doing OLTP DD, another is doing credit card validation or something as part of that. So you can write three different pods. These three teams don't have to talk to each other. They can write their own pods, but your deployment is going to have all these three pods, three containers in each pod. Now you can expose services separately for that pod. So that allows you to reduce number of microservices, because microservice sprawl is going to take a lot of issue, right? Again, you need to define resources. Everybody will say, I need 512 MB RAM, one CPU, and suddenly you will see if you write 20 microservices, you need 50 machines. That's not going to scale. It will work, but it's not going to scale. So you can use, you can write microservices, several of them on a given deployment. Okay, so when it comes to networking, the part where I mentioned source IP NAT is one of the key issues you will face if you don't know how Kubernetes works when it deals with connections, packets, and things like that. L7, so most of the Kubernetes default abstractions are L4, layer 4, right? You get an IP address. So basically do a TCP connect to that and send something. So basically what happens when you do an L4 abstraction is your app needs to directly deal with TCP. So when your app deals with the TCP, there are a couple of problems you will face. If I need to secure this connection, I need to implement SSL, right? I mean, if SSL is de facto standard, if you want to do something else, you have to do it. But let's say you wrote an app that has an L4 abstraction directly exposed to the outside world, and it's dealing with packets, not dealing with REST calls, not dealing with APIs. Right? REST calls are fairly easy because you get an HTTP service interface, HTTPS interface, you put a certificate, and this is a well-known problem. But let's say you want to expose directly a L4 to the outside world, you need to deal with all the SSL headache, right? Not only that, SSL is really CPU intensive. So if you don't want to do that in your pod, so what do you do if you don't need an L4 abstraction? So you need an L7 abstraction. So directly, if I say google.com, google.com should not directly terminate in my pod. It should terminate somewhere else, and I should get an HTTP request. I should not be doing HTTPS request. That's where then you can do something called ingress. Okay, so ingress is a very powerful tool. Basically, instead of saying cluster IP, headless, or load balancer, you will say ingress. Ingress is something you build on top of a service, where you say, I don't want to terminate L4 in my pod. You terminate L4 somewhere else, and you give me a direct HTTP request. So what you achieve because of this is the heavy lifting of SSL is done in hardware. So if you use GKE, GKE uses their hardware, AWS uses their hardware, and if you want to do it on your laptop, you can do an ingress pod, which does not serve the purpose, but you can simulate it. The whole idea of L7 ingress is to take load off your system. And one of the other advantages of doing L7 ingress is, let's say you are building a website, for the sake of example, let's say Flipkart is building, Flipkart is a website. There's a customer end of Flipkart. There's a Flipkart customer support end of Flipkart. So let's say Flipkart.com is customer end and customer.flipkart.com is internal thing, right? So internal website is very different from external website. Now, internal website may be buggy. It may have the latest feature because somebody could not do something and some developer churned up the code in the morning. That's what it is running. It's not going to impact customers. You don't want to put both the code on the same part. You don't want this internal code, which is going to support, which is going to be exposed to customers on the same part. Because usually, I mean, if something that is not tested is probably going to crash in one way or the other when customer uses it. So, but you don't want to tell everybody that when you do NS lookup Flipkart.com, it's a different IP address, right? You don't want to tell your customer support or your end IP address is different because DNS is same, but the backend service is quite different. So in Ingress, you can do directory-based routing. That's why it's an L7 routing. So if you say /customer, it goes to you can convert it to go into a completely different deployment site. And if you say /login or whatever, you can make it go to some completely different deployment site. Keep these two code paths and deployment paths separate, but you expose the same DNS to the outside world. Okay, so coming to source IP NAT issues, this is where I get into a demo. And I kind of talked about it when I said how the packet routing happens. Another problem if you deal with networking. So by default, what happens when you make a deployment? And you can how much time do I have?
Yeah, 15 minutes, 10.
15.
At least 10 minutes here.
Okay, okay, sure. So let's say you wrote a deployment, you got a cluster IP, or you wrote a load balancer, you got an external IP, right? So by default, if you look at it, what happens is when you hit this IP address would have been configured to go to any node in the cluster. And when I say node, it's the physical VM or a box or whatever you have configured. At any given point in time, when that request goes to that node, your service may not be running. When this load balancer is dumb, it does not know. Let's say on the load balancer you sent a packet for microservice A. Microservice A is running 3 replicas, right? And there are 10 nodes. It is only running 3 replicas. So it is running on node 1, 2, 3. Okay. Your request from the load balancer coming from outside, which does not know anything about Kubernetes, hits pod 4. What happens? You don't have a pod which can serve that request there. Your request does not drop. That's where kube proxy comes in. It knows that, okay, your service is running in 1, 2, 3, it will route to one of them. But do you want this behavior in certain cases? So there are 7 pods which are ultimately going to route it to someone else, right? It may be okay if that is not a latency sensitive request or something like that, because other pods are at least doing 5% of the work. 95 this pod has to do, but 5% like receiving the packet, sending it back, waiting for a response, doing all the JSON mumbo jumbo. Maybe that other pod will do. So it's doing some work, but the real work is done only by these 3 pods. So how do you say to the load balancer, don't go to this other pod in some use cases? You shouldn't be going to these pods. You shouldn't be going to these nodes. So when a request hits, it should go to only these 3 nodes based on the service that you're exposing. Now, the load balancer is not aware of Kubernetes. And the second problem is, if you scale out, scale down, if you have crashes, these 3 pods which are running in 1, 2, 3 may be running in 7, 8, 9. By the time load balancer decides to send it to 1, it is running in 7, right? So how do you take care of this issue? So what Kubernetes does is, when it gets a packet, so there are 2 settings One is called, it's the routing setting in which you say route is cluster, which is the default. It means every node will get it. In every node, you proxy will figure out where the pod is running at this moment, and it routes it. Before it routes it, it changes the source IP. That's why it's the source IP NAT. Changes it to source IP to my IP, and routes it. That guy responds back, changes it back to the destination IP, and sends it to the source, sends it to the real source. Couple of problems. So one, we talked about performance problems. If this, convoluted path happens every time, right? The first one. If the convoluted path happens every time, we have a performance problem. Then on top of that, we have a debugging problem. Think of this endpoint, node 1 or endpoint in this case, where somebody says, whenever I send this packet from this client, it gets dropped. It does not work correctly. So your developer goes to endpoint 1, he looks at the logs, he goes to whatever logging tool you have, figures out, okay, and he has no way of figuring out what this client is because the source NAT has changed the source IP to this IP. So if somebody says I'm IP address 1234, he looks at endpoint, he only sees IP address 10.10.10.01. Why? Because every client that is coming to this path looks like 10.10.10.01. So you need, whenever you have a need to have performance at the cost of, let's say, debuggability, you can use source NAT because there are other nodes doing some activities. But when debugging is very important, then you don't want to hit a node where the pod is not running. You have to change the load balancer behavior to local. When you change the load balancer behavior to local, again this problem exists. How does the load balancer know where your pod is running? Because it's not Kubernetes aware. This could be a hardware box from F5, right? Hardware box from F5 was built before Kubernetes, probably. So how do you tell that? So Kubernetes does a very simple thing, which anybody who has installed and configured a load balancer would know. Every load balancer has to have a health check. Before routing the packet to the backend, it will do a health check. Not like in line with the packet, but it is doing a health check on a periodic basis. So whenever you change the load balancer policy to local, Kubernetes says wherever the pod is not running, health check is failed. So load balancer over a period of time figures out that, okay, I should not be going to this backend. I don't know why, health check is failing. So I'll route it to only three guys. If I scale up, the health check starts working again. The load balancer has more backend nodes to go. If something crashes somewhere, then again health check starts failing. So load balancer, without even knowing that Kubernetes is running behind, is directing traffic to the same nodes which have the pods. And because of that, you don't get into source IP NAT. And because of that, you can now debug what is happening. So I'll just get into a demo. The only problem is my internet. Back to this page. Any questions till this point?
L4 abstraction is not egress, right? Egress is different from L4 abstraction.
Yes. I will not talk about egress much because I don't have experience.
No, that's fine. Just the difference between L4 and L7 is just to cut the
Yes, so when you talk about L7, it's the URL, right? You see the URL is L7. You see an IP address, it's L4. So if you want to do URL driven routing, then give me a second. Then you need to think this.
L4 is basically when I don't want to terminate secure or TLS termination.
No, see, maybe going forward, cluster IP will be available both as L4 and L7. Right now, cluster IP is a pure TCP V4 IP. D6 option is coming. So if you need a cluster IP kind of a concept, which is SSL secure, maybe it's coming. Right now, it's not there. Okay?
Right now, it is L4, right?
Right now, it's pure L4. So, so I have GKE Kubernetes cluster. This is the internet open. Okay, so it is running 3 nodes and it's running 1 and 2. So
-O wide.
yeah. So right now it's running one pod called Ubuntu for my debugging. There should be one deployment which is Ubuntu. Again, for debugging, nothing else is running in the cluster. The most important thing to understand right now is if I say this is the namespace thing, I want to see what Kubernetes is running in its namespace. Right? By default, user's namespace is called default, and all the internal Kubernetes things are put in Kubernetes kube system. So there are three nodes, so there should be 3 kube proxies running. Right? So these are the 3 kube proxies. Why is it important? So you can see the IP addresses here. Right? So if at all SNAT were to happen, these are the IP addresses which will get stamped on the packet. Okay, so what you do, okay, so this, whatever demo I'm doing, works only if kube proxy is in IP tables mode, which is the default mode today. Okay, so I'm going to run. Okay, so I'm going to run a server. Okay, so this is an echo server. Basically, what it's going to do, if it gets a request, it will do a get remote address. Anybody who has done socket program will know. Get remote address will give you the remote address of that connection. Right? So that's what it will do. So I'll start one single part of that. So it's doing source IP app. Right? It's running the. So this is not the way you will deploy Kubernetes, but just for the demo, right? You'll write the YAML where you will define the resources, replica set, and all that. But so this app got created, right? So in get pods, I should have one more part. That's why this is a deployment. That's why you see all those random numbers. Yeah. Right? So, and you can see the IP address over there is 10.0.0.11. So now what we will do, we will go. So I'm getting inside my Ubuntu machine, which serves nothing but just my debugging space. So in whatever Kubernetes get pods are showing IP address, this is the IP address of that Ubuntu, right? So this is the IP address from there. That's the IP address I have received. Now, So we saw that IP address for the other service, other product we brought up was 10.10.10.0.0.11, right? So we just started the service, we are not exposed anything, right? So if I do think 10.0.0.11, right? This is going to work. I'm not exposed any interface, but ping works. That does not import number, right? So next, I'm going to expose the port. So I'm basically saying this particular deployment, create a cluster IP, and this may be confusing. The name cluster IP has no significance. You could have named it whatever I want. I'm saying make it port 80 on this target, port 88. Okay. So if I say kubectl, okay, I should have done one thing. Right. So you got cluster IP. The real cluster IP that we are talking about is the type, and we got an IP address. This is the IP table magic. This has no significance. There's no interface which has this IP address per se. Right? So it's exposing port 80. So one thing I should have done is try to get a curl on this, but I didn't do that. Now curl will work. Right? So other pod should not be doing IP address, right? So that's what we will do. It is default. Right? So the app which is running there in that, it basically said your IP address. This is the whole job of that app. Basically saying get remote address, responding back. It's basically saying client address is 10.0.0.9. That means no source netting happened. But you're not sure. Maybe it happened and the IP address did not change. So you can't be 100% sure. But Kubernetes says whenever you use cluster IP, source netting will not happen. Okay, so in our testing also we have never seen the IP address change whenever we use cluster IP. If I get to do this before I expose that code, it would have failed. My bad, I didn't do that. Okay. So now what I'm going to do, I'm going to expose a load balancer. So I'm basically saying, name it as load balancer. Again, port 80, target port is same, but the type is load balancer instead of cluster IP. Right? So load balancer came. You can see the cluster IP has arrived because that is instantaneous. External IP is pending because it needs to communicate to GCE. It needs to get a free IP address, and we should have money in our credit card. I'm just joking. But then whenever the IP comes, it takes time. That's what I'm saying. So then it's saying port 80 32422. Why is it doing that? Right? It didn't happen for cluster IP. It's only happened when I did load balancer. So basically, again, going back to this theme, that the load balancer does not know we are running Kubernetes. Google or AWS or everybody will have one kind of load balancer. They will use the same load balancer if you use AWS, Google Compute, App Engine, GKE, whatever you use. They are not going to have different load balancers. Now, that load balancer knows to only go to a certain port on a node at a very high level. So what Kubernetes does, there is another concept called node port. So it will create the same port. So you as an application developer does not know what port is free on what node. Two people might decide, okay, port 80, or they might decide 3242 is my favorite number, right? So then application will not be able to deploy. So that's why dynamically a free port is taken, it is associated with your code, and then that is exposed to the load balancer. So load balancer now knows it needs to go to every node 32422 as long as the health check succeeds, right? So hopefully we have the IP now. It's slow for Airtel, not because of Kubernetes. So we have the IP, right? So now what we will do? Let's see what if I do curl from here. So this is my laptop, right, which is going via routed by Airtel. Sorry, I shouldn't have gone to the screen. Okay. 35, 193. Okay. Do people remember this IP address 10.2.40.08? This was the proxy address. So initially we printed 3 proxies, right? If you do that again. So the service which is running deep inside should have reported this as the IP address, not this, whatever my Airtel IP address is. I don't know what my Airtel IP address is at this point. It should have reported that as the remote address. But it's reporting proxy address. That means it hit a node where the pod was not running, and it changed its address in that packet and sent it. On the way back, it does not know what to do. It just sends it, right? So the original client address is printed by the service which is running inside, which is in the payload. It's not in the packet, so I get that, right? So every time I do it, I probably get something else. So I got 10.0.0.1. It got hit the same node, but again, it does not know what to do. It does not have. So whenever I get 10.0.0.1, see, I got 10.2.40.07. It means I hit another machine. So load balancer will continue to do that unless I do this. Now I will say LB local.
So what option do you choose there? Okay, so external policy local.
So I'm now saying external traffic policy is local. They're basically telling the load balancer, basically Kubernetes is going to make health unavailable on all the nodes where the pod is not running. It takes some time. This is a pretty small cluster, so here it should happen pretty quickly. So let's see what happens now. See, so the client IP address is okay. This is the Airtel IP address. 35 to 24 and 2680. Right? So now it is hitting, it will hit only nodes where the pod is running. On top of that, proxy knows that it is set in local mode. So it's not going to do SNAT. It sends the same packet to back my server, which is running in the backend. It gets this remote address, puts in the payload and sends it. So proxy is not doing anything. So this will achieve. So if you were to do a log in your server, you would get this IP address, and you can help your customer guy. Why is it not working? You can differentiate your clients, but this will come at a cost. The nodes where your pod is not running are not taking care of 5-10% of the activity, right? So you can set it back to. Okay, so let's see what happens. Not the right way to do it.
Local.
I'm going to increase replicas to 3. So desired count and current count means everything got deployed. Now we have 3 parts running for source IP with IP addresses 10.0.0.1, 1.5, some random numbers like 2.5. So now what happens if we do the external IP address did not change, right? So this is on 4G, so its IP address is the mobile IP, so it keeps changing. So now even if I have run pods on every node, I can continue to get my client IP address, right? So even though I mean previously we had pod running somewhere on some of the nodes, so it had to route. Despite routing, we were able to get client IP address. Now it's running on each node. In this mode also we can get the client IP address. See, getting client IP address is not very important. Understanding that this behavior exists, and for your particular use case, maybe you need to do it for some reason. So pod is running on every node now. There is no matter which node you hit, it should not get routed. It's there locally, but that's not the behavior. It's important to understand, even if you are running pod on every node, your default behavior will be overwriting the type. So you can't solve this problem by running pod every day. Yeah, so that's pretty much what I have. Yeah.
So,
Just a question here. So you were saying you want to put a pod on a given node, right?
You generally don't say where your pod should run. That's against the whole orchestration thing.
So you can use node selectors to actually direct the pods to given nodes.
Yeah, usually you don't want to do that. See, if you want to run on the same port on every node, not the load balancer perspective, you can use node port instead of a random port. And you can do it that way, but that basically means you have to run that pod every time. There may not be use case where you want to run it everywhere. Right? Clusters are just going to grow and grow. You don't want to run them everywhere.
So what I meant was you can use node selector, right? So at the pod level, you can actually say.
Yeah, but the external load balancer has no idea that this is something that's how you deploy it. It's going to be really dumb when saying, I'm going to push it to, so whatever that random ephemeral port that you saw, load balancer is configured saying, this ephemeral port on every node you can go, as long as health check succeeds. It does not know whether you have used node port or you are running deployment or headless. It does not know what that is. So it will hit some pod, it will hit some node. Then that kube proxy behavior is going to determine whether it's going to succeed, route, change the source map, something like that. So now you are basically saying, I'll fail the health check and set kube proxy in a different mode to achieve this.
What SQL you are using?
We build it, we don't use the open source SQL.
Let's say you have 10 machines, instances. Out of those 10 nodes, 5 are dedicated for a Kubernetes cluster, and rest of the 5 are running some persistent services.
No, I didn't get you. What do you mean by what are the other 5 nodes doing?
5 nodes are running some persistent storage services.
So in Kubernetes, you basically give a pool of nodes to the master, right? Convenience. So you technically, if you do this in the right spirit, you are not going to say which node should run what.
5 nodes which are part of Kubernetes cluster are usually going to run stateless services.
Okay.
Rest of the 5 nodes are having some excited service that is running.
Okay.
So how do my Kubernetes service can access that specific service running on that node? And if that node, which is not a part of Kubernetes cluster, has to access some service which is running in a Kubernetes.
So if I can rephrase your question, maybe I'm wrong. you're basically saying you have 10 nodes, out of which 5 Kubernetes is managing.
Yes.
And in that 5 node, you are running something stateful service. And you have other 5 nodes. So that is not, that's like saying I have a Kubernetes cluster and I have something else which needs to talk to this. The something else could also be a Kubernetes cluster, but it doesn't matter. So you basically means you need to figure out a way of exposing this. That is not a Kubernetes construct. You have to say, okay, how is that guy going to contact this Kubernetes cluster? Am I going to expose a load balancer? Am I going to expose layer 7 ingress? Right? So though you need to expose those interfaces. Otherwise, your Kubernetes cluster, if you configure everything, make everything cluster IP or everything headless, nobody can talk to it. I mean, Kubernetes commands will be able to talk to it because they go through master. Your services as such don't have an exposed interface for outside world.
And whatever SQL we're running, that is your customer.
Yes, so we build our own product.
That by assuming that you're not ready to handle all the
No.
So it's a proprietary partner. That's your partner.
Yeah, so the way we want our controller is which we will develop. We will expose interfaces for other people to come and develop their own services. So they can change the behavior of how we do things. That's the because what we are developing is proprietary, right? But it is other people to come and experience.
How do you have an experience that configuring that typical hardware load balancers?
So right now we are just using GKE, so we are not physically.
Fine. I'm just saying that in general, if you kind of think about that problem, then we'll kind of have a physical hardware. People have hardware load balancers,
yeah,
and they want to communicate with Kubernetes,
yeah,
and running on-prem.
Yes.
So
and I'm not the best person to answer. What my belief is, Kubernetes is giving a plugin interface for all these guys, so that they can handlers, which Kubernetes will call, which has a specific interface, and they can do their configuration. And that's how everybody, that annotations part, right?
Yeah, annotation, basically your load balancer should look, say, if service changes, then let me know. I'm going to change that.
Yes.
So do you know any kind of product which is already available, or?
I'm not sure.
Okay. That's fine.
What networking use case will solve?
We are solving some throughput use cases, throughput QoS use cases.
Okay.
How do we consistently give a throughput on the internet or on your private lease line? Okay. Just to give a very high level example, when you get a broadband in your home, that guy says it's 100 Mbps, you will not get 100 Mbps throughout the world. If you do speed test, you will get 100 Mbps. If you access a website, it does not load at all. The reason for that is nobody can guarantee an end-to-end throughput. They only say until their DSLAM is 100 Mbps. That's it. Beyond that, it depends upon how many ISP exchanges they have, the contracts across exchanges, and end web server or end device itself. That itself is. So we try to solve this problem. Okay. So if you link, and you can guarantee you that two destination 100 Mbps. Even though that 100 Mbps so bandwidth that you got. So ISP does not know what you're going to do with that. When somebody gives you an internet link, they link internet. Can I upload quality? They call is nice. An MPLS link. No matter what. So then you keep that. Right? You just link to your Bangalore is others. So it's such a timely link by today's standards, but it creates so much money because for Of course, we cannot replace all retailers behavior, but problem. Not and I need a dedicated connectivity link between Bangalore and US at 100 the cost. We can do it within this. Yeah.
Like you were exposing it of GC load balancer,
Yes.
or you are using any F5 or something?
No, GC.
GC.
GKE to be specific.
Yeah.
Everybody wants to move to from C to K. It's become GKE, A. What is that? EKS? Yes.
EKS and PKS.
Okay. So no more questions. Thank you, guys.
Thank you.
And, I probably have one more slide. Okay, so what we would like to see in Kubernetes from networking perspective. I'm done. So, so network service groups, right? We need, for example, you write 10 microservices. Every microservice can talk to every other microservice. That's the nature of it is today. I want to define which microservice is allowed to talk to which microservice. Let's say I'm exposing some Kafka service. Somebody comes and codes post to Kafka, destroys everything, and then I'm debugging what is happening. And not just from a debugging perspective, from a security perspective. I should be able to define whitelist and blacklist between services. Who can talk to whom? Not everything is open. So that's not there today. Service chaining is a very service chaining is not.
Network policy is there, right?
Yeah, but
what's the Calico network toolkit? So use network Calico and you can implement that which particular port you communicate to which particular namespace and all.
Yeah, but we would like to see it in default. Right now, only Calico does it.
Yeah.
And service chaining, which is basically if you are developing anything in networking, you don't want to use it in code. Who needs to talk to whom? Anybody who has developed a TCP stack or anything will know, especially go back to Unix days. I can push in a new module in between. No code changes, right? I can put a compression module in between IP and TCP, and nothing changes. Payload gets compressed. Did anybody go and reconfigure TCP and IP? No. But if you hardcore saying TCP will talk to IP will talk to TCP, then you can't make that change. The service chaining will allow you to dynamically make the communications go through a different path, and you can test something. Something is not working right. I'll put a debug module service in between, run through that. So that's something we would like to see. And the third one, last one is can be done in some ways. Today we specify resource limits for CPU, resource limits for memory. We would like to specify resource limits for bandwidth. Resource and QoS requirements for bandwidth, right? This service needs to have unlimited all the time. Schedule it on a particular machine is not using other resources, right? Others also have to put resource limit on networking, and we would say, okay, only schedule it if it's available. Then putting a restriction is easy. Giving this feature is easy. How do you do it in real life? The Docker and C groups is what allows you to put memory limits and CPU limits. That basically means this feature has to go down in the stack, and only from there you can build it out. There are some talks about what people are doing around this to solve it.
Last question. So networking telecom industry is all standard driven, right? And your product is going to play there. So what are the standards you're following? Are you following HC standards?
See, for controllers, there are no standards. Right?
Not HC manual defines those, right? We were talking about service chaining, which is
I get it. So
forwarding graph and things, right?
Yeah.
Those are all defined. So are you following any of those standards?
No, from my perspective, Kubernetes is not at a level where you can do all those.
Talking about use case. Kubernetes, all those are
our use case does not have service chaining. Okay. What I would like to do is, if somebody were to design the system in such a way, I would like to move that out from the code into configuration. That's what I talk about when I say service chaining or chain the path. My use case is to solve, end of the day, the traffic QoS problem, which has its own standards, which I will solve. But implementation of my own controller, that's not something that's proprietary as of yet. Okay, finally, we are hiring, so you can talk to me or send emails. Yeah, thanks.
Yeah. Let's give you a look at some website.
Okay.
So thanks guys. So thanks Vishwas and MBK joining us. So unfortunately we don't have two of our speakers, which kind of takes the last moment. So it's a good thing that we could have Vishwas for long time. But demo what he gave is, I'm not. You might, if you're new is not, then you might not appreciate that. But if you have been using Kubernetes some time, you saw the power, what you can do, and how you can change it. So you need to kind of a user who can understand that kind of thing what we discussed. Right? It's good what you talked about is really important and things like that. So I've seen that people have asked few questions in between to me that how I get started. I mean, don't take it otherwise, but I've been seeing that people kind of learn about few stuff, but eventually kind of they have half-cooked knowledge. And that creates a lot of problems for you to understand even for Docker and Kubernetes. So you need to make sure that you learn the right way. Otherwise, what happens is you learn something from here. And even if you know about Docker, right? Docker has changed last four years, it changed completely. So people have been trying Docker for some time back, and now they say it's not happening that the way I have liked to do it. So you need to keep us updated with the right content, what is available, and what you need to learn for that. Okay. So being said that, so I have a course on edX, edX.org, which is Linux Foundation funded a project. So people who was behind CNCF, they funded this project on Kubernetes. Let me just search on that. So, where is this course? I have authored this course for them. This course has been taken by about 20,000 people from 147 countries. And it's a free course. You can basically take this course at your own pace. So this will basically cover up all the Kubernetes concepts that you want to know before you talk to someone or understand the Kubernetes concept. So this is one of the free courses they have. They have some paid course also. And there is a certification for Kubernetes called Certified Kubernetes Administrator. You can take that exam once they've taken this course. And similarly for Docker, right? Docker community has good content to learn about that. So if you go to GitHub, Docker. Community. So if you go to this GitHub community, you will find a lot of good contents there about learning the Docker the right way. Okay, so basically this changes every time, right? So you can learn the Docker from this particular thing, and for Kubernetes you can take the edX course which I have mentioned earlier. And if you want to kind of know more, then you can always connect with me because we provide services there to learn and clear the CK exam per se. But these are the free resources which are available to you. And I think before kind of going anything through the class, finish that thing end to end, then you kind of ask questions in the right way. It's also important, right? Because it has to make sense, the question has to make sense. Otherwise, if people are not talking the same language, then it doesn't work out. Basically, do your homework first, and then things can work out for you. Because thing is that a lot of keywords learning is fine, but if the base is not correct, it's not going to work out. So just keep that in mind and finish out these 2 free resources which I have given to you. Should be good to help you to kind of take it forward. Okay, any other questions you have? Because yeah, we spend a lot of time here, but I think it would have been helpful for this train, whatever what we did today. Something at least you would learn. So I definitely learned about that, at least the local, what example here, local mode, which I didn't aware of that, is good. So I think something you have got today to learn. Any comments and suggestions you have?
The meetup we have is when we started was on Docker, right? I remember the early meetings. Now I think we are talking about a whole lot of.
Yeah, correct. So the way it was kind of highlight here is, yes, the idea for this particular meetup is to kind of say, because now, I mean, it's the industry would evolve, right? So it's not that I have looked at Docker only. They've changed, right? Like Docker, and then they're using Kubernetes now.
Which is a comment, sir.
Yes, it's a good comment. It's a good comment. See, for us, it's a learning important. And for me, at least, it's learning important. It's respect of the Meetup group, what you are part of it. So as long as that's happening, we should be happy. Other than worrying about our Docker group or our Kubernetes group and all that, doesn't matter for me, at least. We should be learning about this thing, and that's all that matters. So the same thing, what we're doing, the plan to do is on 24th of March, we're doing a combined meetup where AWS, Dissolution, Docker, Kubernetes, Elastic, and all of it is coming together, and we're doing a big event. It's not a free event, it's going to charge a bit so that we know that people will come in. Because free event, we saw 60 people, 60 will get, 70 will get. So to have that thing, we're going to charge 50 rupees for each participants. And even that money getting charged, what we will do is we're going to give money back to the speakers of the gift and participants or private participants. So nothing is going to be earned from that. And we have a host, I mean, already that's not finalized right now, not official what we have. That's going to be all settled. So we could see the announcement for next couple of weeks. We'll announce the CFPs and we'll announce the registration link and everything as we go along. Okay, any other comments, suggestions, any questions you have?
No, we always wanted to expose this networking stuff actually, and this time I would say it's really good to see. And it was a quite good learning today.
Okay.
Yeah. So I mean, networking is a kind of thing which is always complicated, and
Yes,
need to focus
I know
on.
what you mean.
Yeah.
I know. Yes.
So I would really appreciate. I mean, if we keep exposing networking part in each meeting.
We not we actually did a couple of networking specific sessions already. If you kind of go to the earlier Docker meetups in the history, you will find the specific meetup. Though we might not have videos there right now, so that was a large. I think we have a year and a half back, but you will find the slides and everything there. You can go there, but yeah, we can keep repeating the stuff as kind of so today we saw a lot of first timers are there, right? There are few people who kind of keep coming because they know the qualities of what we delivered, but there are few first timers also. So basically, for that, you kind of keep the basic and advanced kind of mixing.
So on the pod networks, a question. So for production nodes, typically what coordinators you recommend? Panel versus B.
Okay, so these work on different protocol they have. So Weave and Flannel works on overall network or VXLAN. Calico works on BGP. So this implementation different is there. The idea is to kind of you deploy the copy of your whatever you want to do in multiple modes, BGP or VXLAN. Do some kind of benchmarking, and that passes everything is to use that. So people have been using Calico as a primary one because that also provides network segregation right now. So you can say that containers for pods on this particular namespace can talk to the other ones. That's also there.
So
But you have to.
So one thing I would like to say is you need to first figure out whatever you're building is network throughput intensive or latency intensive, right? So that also makes a big role. For example, VXLAN, we give you a lot of performance, but at the cost of CPU, right? So it depends on what you want to build. For example, in our controller, the controller per se is not transferring data. It is not getting all the data into Kubernetes and transfer. So we would not be building it this way. So for us, latency is important, but not the amount of data that is coming in. So you need to decide. And like Jitendra said, you need to do some experiments on bare bones. Don't go do experiments on some cloud provider because behavior is going to be very different because they are going to have some acceleration which we will not be able to replicate. Yeah. For example, somebody will have SRIOV card. You will say, okay, this is work for me. You come and deploy it in house, it will not give the performance. So you need to set your hardware requirements and then say on this hardware what's the best performance I want based on my application. From there move on, because most cloud providers are going to give you better performance than what you can achieve in your data center.
Performance is a black card. You get a number what you want. Depending on environment you choose, you can kind of publish that number. That's there. But when you actually do it, you do it. Okay, we'll just close that for today. Thanks. Thank you. We have hosted it. Thank you.
So you can submit the ID card tracking, etc.
Hey man.